Hello, I'm Jack Koenig from Graco Lubrication Equipment Division. In a previous video, I covered the basics of the Manzel MBL or Modular Box Lubricator. This video will focus on one feature, the drive. The MBL family offers a lot of options for the way we turn the camshaft, which are called drives. Some drives are straight or in line with the reservoir and then connected to a motor, which is also in line. This is what we see here in our example. Other drives are configured as right angle drives because they will be driven by a PTO on the machine and the reservoir needs to be situated flush with the machine. Some drives are for use with motors that are foot mounted, such as our example, and some are mounted on the C face of a 56C motor. Some drives are not for use with a motor, such as the Ratchet Arm or the Rotary ratchet drives. Why so many options? Well, because different applications have different needs and different power sources. This really just provides a lot of options to our customers. I just rattled off a bunch of options very quickly, so now let's slow down and dig in a little deeper to see what is offered for the MBL.
First, an explanation of drive ratios. The drive ratio is a statement of how many turns of the drive shaft are required to get one turn of the camshaft. For example, 400 to 1 means that for every 400 turns of the drive shaft, there is one turn of the camshaft. The MBL camshaft uses cams that are single lobe, so every rotation equals one stroke of the pump. The GBL 7500 pumps are rated for a minimum of 3 strokes per minute and a maximum of 50. This means the camshaft has to turn at a speed within 3 to 50 RPM. Regardless of which drive is chosen, the camshaft ultimately needs to run at 3 RPM to 50 RPM. So determine your input speed, divide it by the drive ratio, and make sure the resulting number is within the range of 3 to 50 RPM. This will be covered in more depth in another video. For now, let's get back to the various types of drives. There are essentially 4 or 5 types of drives for the MBL, depending on how you count them. The simplest drive is the 1-to-1 or direct drive. There is no reduction on this drive because it's simply the camshaft extending beyond the end of the reservoir with a keyway that can be attached to a coupling and driven by a PTO or to a sprocket or pulley to drive it with a chain or a belt. It just needs a power source to turn the camshaft, and the cams will stroke the piston pumps. A gear or pulley can create reduction when used on the shaft, but the drive itself has no reduction. Because the direct drive has no reduction, the input speed is the same as the camshaft speed, and therefore the input speed must be within the range of 3 to 50 RPM. There are also several options of ratchet drives. The term ratchet drive usually refers to the ratchet arm, but there are also drives called rotary ratchet. We'll get to the rotary ratchet drives in a moment. The ratchet arm works under the same principle as the ratchet wrench you use with your socket set. The arm moves back and forth, driven by some mechanical power source on a machine, and the ratchet wheel inside the box is controlled by a pawl that only allows it to turn one way. So the ratchet arm moves back and forth, but the ratchet wheel and the camshaft only rotate in one direction. While the ratchet drive is driven with an arm that turns the camshaft directly, the rotary ratchet drives are driven by turning a drive shaft. The rotary ratchet drives are offered with either a 75 to 1 ratio or a 37.5 to 1 ratio. These numbers come from the ratchet wheel, which has 75 teeth on it. Inside the box, the drive shaft uses a cam to move a ratchet pawl. On the 75 to 1 drive, the pawl only picks up one tooth of the gear, and so it takes 75 turns of the drive shaft to complete one turn of the camshaft, thus the ratio of 75 to 1. The 37.5 to 1 drive uses the same gear, but the pawl has more travel and basically skips a tooth and moves the gear 2 teeth at a time. That's why the drive has the odd ratio of 37.5 to 1. MBL rotary ratchet drives have a maximum input speed of 800 RPM, which means they won't normally be used with a motor. However, a motor may be used if it is lower than 800 RPM. For motor-driven units, there are drives with higher ratios. But which drive to use depends on how large the reservoir is. So far, the drives we've discussed can all be used on any of the MBL reservoirs, from the smallest 4-pint 2-pump reservoirs all the way up to the 40-pint 24-pump reservoirs. But with the higher ratio drives, we have 2 groups of drives. One group is called double reduction and rotary, and they are good for up to 16-pint 12-pump reservoirs, what used to be called T5. These drives are bolted to the end of the reservoir, so they can be ordered with or without a motor mounting base, because not everyone uses a motor to turn them. The optional motor mounting base we offer for these drives is designed for use with motors having a NEMA 56 frame size. The motor attaches to the base via feet, so it needs to be either a 56F, as in Frank or feet, or a 56C with feet. The other group of drives for motors are the heavier duty gear reducer drives. These are for use with the 3 largest reservoirs. This is because the larger reservoirs can hold more pumps and therefore require more torque to turn the camshaft than the smaller reservoirs do. The gear reducer is mounted to a motor mounting base, not directly to the reservoir, so the base is a requirement, not an option, on the gear reducers. The only way to drive these gear reducers is with a NEMA 56C motor, because the C face is used to attach the motor to the drive. The final type of drives are the right angle drives. As stated earlier, they will probably be driven by a PTO on the machine, and the right angle configuration allows the shaft to be driven from the back side, allowing the reservoir to be situated flush with the machine. These could be used with a motor, but Graco does not offer mounting bases for these drives, so it would be up to the distributor to figure out if this meets the customer's needs, or if it would be better to use one of the other drives with a motor mounting base. Again, consider the input speed combined with the ratio of the drive. If the input speed divided by the ratio is not within 3 to 50 RPM, choose a different drive. Hopefully this video on drive options has made it easier to understand the MBL and all of its possible configurations. Please refer to Manual 3A2100 or the ILE Buyer's Guide for more information, or call Graco at 800-533-9655 if you have more questions.